Hi, student and dear viewers. Once again, Dr. Pradeep Kumar is before you for attending second lecture on infinite series. In the first lecture, we learn about how a infinite series will be convergent and divergent. In the previous classes, we learned an infinite series will be convergent if its nth sum will be finite, and divergent its limit of the sum up to n terms when n tending to infinite is infinite. In this context, we learn that a geometric series whose common ratio is less than 1 in convergent, and the geometric series will be divergent if its common ratio is greater than and equal to 1. And we also learned in the previous class that the sum of two convergent series is a convergent, sum of two divergent series is divergent, and the difference of two convergent series is convergent if both series are convergent, and divergent if both series are divergent. We also learned that in the previous class that if a convergent series is given and if we multiply it by a constant number, then the resultant series will also be convergent. And divergent, if the constant term un is divergent, if constant by multiplication, it will be always divergent. In this class, we proceed further for more theorems of the convergence and divergence of the series. In today's lecture, we try to understand the new concept and new theorems. In this context, we read two important comparison tests for the convergence and divergence of the series. Let us first theorem, comparison test 1. If two series sigma un and sigma vn be two infinite series of positive terms, and sigma vn is known to be convergent, then sigma un will also be convergent if 1 un less than vn for all n. It means each un is less than each vn. Second, un divided by vn less than a constant number. And third, un by vn tends to L, a finite number. Let us come first. If un less than vn, it means all un is less than all vn. It means if we sum both series, that is sigma un less than sigma vn, and sigma vn is given to be convergent, and sigma un is a lesser series than sigma vn, and we know that a lesser series it depends on the latter series. Since sigma vn is convergent and sigma un is lesser series than vn, then sigma un is automatically a convergent series. Second, if un by vn less than a k constant number, then un less than k vn. It means sigma un less than k sigma vn, and sigma vn is given to be convergent, then k sigma vn is also convergent, and sigma un is which is on LHS is lesser series than a convergent series, so sigma un is also convergent. Third, un by vn tends to L. Then it means that it should be elaborated on limit idea. Un by Vn tends to L means L minus epsilon less than Un by Vn less than L plus epsilon. We take the writer's component, that is Un by Vn less than L plus epsilon. It means Un less than L plus epsilon Vn, that is sigma Un less than L plus epsilon sigma Vn, and sigma Vn is given to be convergent. Then series on RHS is convergent series and series on LHS is lesser series, so it is sigma Un is also convergent. Now come on comparison test 2, which is of divergent series. In the similar way, sigma Un and sigma Vn be to infinite series and sigma Vn is given to be divergent. Then sigma Un will also be divergent if there are three conditions. First, Un greater than Vn, that is each Un is greater than each Vn. Second, Un by Vn greater than k fixed number. Third, Un by Vn tends to L finite number. First, when Un greater than Vn, that is sigma Un greater than sigma Vn, and sigma Vn is divergent and Un is greater than a divergent series, so sigma Un is also divergent. Second, Un by Vn greater than k. It means Un is greater than k Vn, that is sigma Un is greater than k sigma Vn, and sigma Vn is divergent, and series on RHS is divergent series, and sigma Un is greater series than a divergent series, so it is sigma Un is divergent. Third, Un by Vn tends to L. It means L minus epsilon less than Un by Vn less than L plus epsilon. We take Un by Vn greater than L minus epsilon. It means that Un greater than L minus epsilon Vn, and sigma Un less greater than L minus epsilon sigma Vn, and series sigma Vn is given to be divergent, so series on RHS is divergent, since sigma Un is greater series, and so it is also a divergent series. Now we have completed both comparison test. It is an important test, and next we come on D'Alembert's ratio test. It is simply known as ratio test or D'Alembert's ratio test. It is very important theorems in infinite series, and its statement is as this: if sigma Un be an increasing infinite series of positive terms and Un plus 1 by Un less than k and k less than 1, then sigma Un is convergent, and if Un plus 1 by Un greater than k and greater than 1, then sigma Un will also be divergent. We come on first. Un plus 1 by Un less than k less than 1. It means U2 by Un less than k, U3 by Un less than k, and so on. Now we take series sigma Un. Its expanded is Un plus U2 plus U3 plus so on. Now we take Un as common, then Un common 1 plus U2 by U1 plus U3 by U1 plus so on. Next we step U1 is equal to 1 plus U2 by U1 plus U3 by U2 into U2 by U1 and so on. Next, chunki as U2 by U1 less than k, U3 by U2 less than k, it means the next step sigma Un is less than 1 U1 into 1 plus k into k square plus so on. So the series is a geometric series, and it is a geometric series which common ratio is k, and k is given less than 1. So series on RHS is convergent, and sigma Un is lesser series than a convergent series, so sigma Un is convergent. Now we come on next. When Un plus 1 by Un greater than k and k greater than 1. In the similar way, U2 by U1 greater than k, u3 by u2 greater than k, and so on. Now we take series u1 plus u2 plus u3 plus so on, and we take u1 as common, 1 plus u3 by un plus u2 u3 by u1 and so on. Next, 1 plus u2 u1 common, 1 plus u2 by u1 plus u3 by u2 into u2 by u1, so on, and it is greater than u1 1 plus u sigma un is greater than u1 into 1 plus k square and so on. The series on RHS is geometric series whose common ratio is k, and k is greater than 1. So it is a divergent series. So series on RHS is divergent series, and the sigma un is a greater series. So sigma un is divergent. Now we completed comparison test 1 and 2, and this is the Alembert's ratio test, and I have put all these components which I have told in PDF form. You can see and verify it, and you can ask me anytime, and thank you very much. Thank you.